Alright, how to find the vertex and axis symmetry of a parabola. What I have here is just kind of the general equation of a parabola. Um, and so we've got y equals a x minus h squared plus k. The vertex is hk, and this axis symmetry idea is x equals h. Well, what does all that mean? Well, I think the funnest way to create a parabola is to fold paper. Well, it's kind of tough to, I could show you folding paper, but this is a little more effective, I think. What we have here is DC. I have a line. This line we'll call the directrix. C is the focus. And D and E is the perpendicular bisector between D and C. So you imagine folding D on top of C, and this D can never be off this line. So if you could imagine just folding this a whole bunch of times, it would look something like this. And that shape formed in the middle there, that is the parabola, or formed from a quadratic equation. Now C is very close to this directrix, the focus. So let's move C a long ways away from the directrix and change things up again. Notice now you have a very wide shape forming, or parabola forming. And when you line up D, E, and C there, that E is your vertex, D is a point on the axis or on the directrix, and C is your focus, and E is directly in between those two at your vertex, at the lowest point. So that's just kind of a cool way to look at a parabola. But oops, wrong one. Here's that equation with some numbers put in it. So what's kind of nice, this A value, this 0.69 I have here, I'll change it to 1. So this 1 here tells you how wide or narrow the graph is. So notice as I go bigger and bigger and bigger, it becomes narrower and narrower and narrower. Everything else stays the same. And notice as the number gets really, really small, it gets wider and wider. So there at 0.08, we have a pretty wide graph. And then when it goes to negative, it switches, so it's pointing down. Or we call it opening down in mathematics. And so I always say the A value, which there's positive 1.54, tells you whether it's happy or sad. Positive means happy, so notice it looks like a smiling face. When A is negative, it's sad, so there's negative 1.92, so we have a sad face forming, a sad mouth. So that's a sad graph, that's a happy graph. They're all happy graphs, but anyway. H value, notice that moves it left to right. So if you're at negative 4, you've got x plus 4 inside these parentheses. If you're at positive 4, you've got x minus 4 in those parentheses. And then k moves it up and down. So right now it's at 5, so it's plus 5. There the signs aren't opposite. There's k is 1. There's 1 on the graph. K is negative 1 means it goes down below the, y value is negative. And so that's what A, H, and K do in this if the equation's in standard form. Or general form. I guess I call it standard form, but there's a lot of different ways to look at this. Now, so here I gave you y equals 1. You don't need the 1 there, but I stuck it there anyway. So y equals 1, x minus 3 squared plus 2. So we know our vertex is 3, 2, where you got x minus 3, so it becomes positive 3 here. And our k is 2, so that stays 2. And our axis of symmetry is 3. I guess axis of symmetry I haven't really shown you, but we can go ahead and, if we were to graph this thing, here, and I have it partially graphed for us already. So here's the point 3, 2, right? 3 up 2. And here's the line x equals 3. Well, notice you could take that, so now I've just kind of roughly sketched it in there. And let me get rid of those little marks. So there's our parabola. And these two values are exactly the same distance from the axis of symmetry. So you could take this along that dotted line and fold it, imagine folding that parabola on top of itself. That's what the axis of symmetry does. So anything over here, as you graph up, could be graphed with anything over here on the right side. So that they match up exactly with that, along that line of symmetry. So that's generally how to find it. So let me give you one more. So let's say you had y equals, say, 1/2 x plus, and we'll make it negative, x plus 4 squared minus 3. Okay, well, my vertex would be -4, -3. And my axis of symmetry would be x equals -4. So if you graphed that, I'll just kind of rough sketch it here. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you go left 4 and up 3. Sorry, it's so pathetic looking. Then you have an axis of symmetry there at x equals -4. And since this is a -1/2 here, I know this is going to open down. So it's generally going to look like this. So in later videos I'll show you how to get a little more precise with what it looks like. Now, there's another form of this equation, and it looks like this, where if you were to solve for x instead of y, where your y was squared and your x was not. So x equals a y minus k squared plus h. And so again, your vertex is hk, and your axis of symmetry, though, this time is y equals k, is your axis of symmetry. See, these graphs open left and right, so generally this is what you would have. So this is your x-axis, this is your y-axis. This would be your dotted line for your axis of symmetry, because this would be y equals k, and this is your hk. Obviously this is if a were positive. If a were negative, it would open the other direction. Okay? So if you had an equation x equals 2 y minus 3 squared plus 5, I would know my vertex was 5, 3. So everything kind of reverses there. And my axis of symmetry is y equals 3. So I know if you just generally graph this, 1, 2, 3, 4, 5. So we'd have a vertex here, axis of symmetry here, and we know it opens, since it's positive 2, it opens to the right. So that's just a quick glimpse of how to find vertex and axis of symmetry. Now, you could have problems like this. Let's say you had y plus 1 squared equals 6x plus 1. Well, we're going to have to solve that for x, because the y here we can tell is squared. So we're going to solve this one for x, and this would be like our second situation. So I'm going to distribute the 6 through. So you have 6x plus 6 equals y plus 1 squared. Then you go ahead and solve. I'm going to flip it using the symmetric property, because that drives me nuts to work right to left. And then you subtract 6. And so you got 6x equals y plus 1 squared minus 6. And then you divide everything by 6. And so x equals 1/6 y plus 1 squared minus 1. So I know my vertex, so see if you can get it ahead of me. Maybe hit pause. But my vertex would be -1, comma, -1. And my axis of symmetry, oh, this one's kind of nice, is y equals -1. So this became -1, this stayed -1. And kind of nice that it ended up the same. But so that's that one. And you could graph that. I mean, this would be a fairly, because of the 1/6, this would be a fairly wide graph opening to the right. But what happens if you have something where you have to complete the square? Okay, so what if you have this in general form like this? Well, we're going to go ahead and solve for the variable that's not squared, in this case the x. And so we'd have 6x. I'm going to move everything else to the right. So you're going to add 3y squared. You're going to add 12y. I'll leave the 4 alone for now. So you'd have 6x plus 4 equals 3y squared plus 12y. Well, if you remember completing the square, the first thing you have to do is factor out a 3 out of that thing. So you'd have 3y squared plus 4y. And then we're going to complete the square on it. And then we'll leave the 6x plus 4 alone. And what you do is you take the middle term, which is the 4, divide it by 2 and square it. So I'm going to do that off to the side here. So 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 here. And remember, whatever you add to the right side, should add to the left side. Well, you'd have to add a 12 over here. And you might go, well, where the heck did that 12 come from? Well, remember, you took a 3 out at the beginning. And if you were to redistribute that 3 through, at the end you'd have 3 times 4. And 3 times 4 is 12. And so that's what we're adding there to that side. And so if I kept going on this, then 6x plus 16 equals 3. And then you factor this, this part here. And that factors to y plus 2 squared. And then subtract your 16. And so 6x equals 3 times y plus 2 plus 16. And then you divide by 6. So x equals 3 divided by 6 is 1/2. Y plus 2 squared plus 16/6. So you can take 2 out and get 8/3. Okay, so I know the vertex for this thing is 8/3, comma, -2. My axis of symmetry is y equals -2. So if you just quickly graph this, 8/3, 8 divided by 3, 2 2/3 approximately. So we're having to do a little bit of approximating. So it'd be right 2 2/3, down 2. So my vertex is about there. Y equals -2 is my axis of symmetry. And so I know my graph looks generally like this. And that's how you find the vertex and axis of symmetry between the two. And there's more videos on the way. But hope this helps you get started at least on these. Good luck and see you next time.